12.3 is going to talk about multiplying monomials and polynomials. Our monomial is going to be what we're going to use to do the distributing. So we're going to start with a real life one, horse corral. You are enclosing a rectangular horse corral that will be connected to a barn as shown. Your barn is that red area. You have 200 feet of fencing, and that's the dotted line. So this says, oh, we have a misprint here. This is let C going to be our variable, and this should say represent. Got a little typo there. Represent the length of the corral. So what is the polynomial expression? Let's go ahead. I'm going to change that instead. Let's go ahead and just do L as length. We're used to that. So let's just cross this out. We need to represent the length of the corral. What is the polynomial expression in terms of, and we're going to change this to L, that represents the area of the corral. So it's going to be twice the length, because we have length on this side and this side. Width we only have one, because this side will not need a fence on it. So we have two lengths, one width for our fencing. So the fencing is F. We have 200 feet of fencing, and that needs to cover two lengths plus a width there. All right. So if I want to go ahead and change this, that I can solve it for the width, I'm going to go and subtract like 2L from both sides. So I'm going to have the expression W, we're going to put that W, I don't like that, W equals 200 minus 2L. Okay, so now I have just one variable there, and I can use that then to do my area, which is length times width. So if I look at my area, I can say it's going to be the length, which we don't know, times the width we know is 200 minus, sorry about that, little problem with the calibration, minus 2L. I guess it's a lot of problem with the calibration there. Now, what we're going to learn next, on the next one, the next screen, is going to be how then we can do some distributing. So because this one's having some problems with the calibration, I'm going to move on to that one first, and then I'll come back and I'll solve that one. So on this screen, you can see for each one of these, I have a monomial. There's a monomial, one term, and it's going to be multiplied, and we're going to multiply that with a binomial. So here we have two terms. Now remember, we're going to distribute. So we're going to distribute our 3x. So we have our 3x times our 5x. Go ahead and look at their coefficients. We'd have 15. But an x times an x gives me x squared. I'm going to keep my positive here because a positive 3x times a 6x is going to give me my 16x. Now, the ones on this side, I'm going to do the same thing, but my distributor, my monomial, is on the right-hand side of the equation. However, the equation in the parentheses is in the order of degree that we need to do. So I would take my 2z and I would multiply it by the first term, negative 4z. That's going to give me, negative 7z. That's going to give me a negative 14z squared. 2 times negative 7 gives me the negative 14. Z times z gives me the z squared. And then I do my 2z times 1, so that will end up giving me just plain 2z. Same thing, they tried to split here with the distributor on the end. So the negative 5t squared, so times t. Now remember, that's a single t. And also, let's put a exponent in there. The exponent is going to be an implied 1. So negative 5 times 1 is going to give me my negative 5. And then I have a t squared times a t to the first. When that is the case, remember I'm multiplying, so I'm going to add my exponents. That's going to give me a t cubed. Negative times a negative, I have my negative 5 times a negative 4. That's going to give me a positive 20. And then my 4 doesn't have a variable term, so that variable would just be multiplied by 1. So I'd have plus 20t squared. So our last one, our monomial term, is an a squared. I'm going to multiply it by another a squared. I don't have a coefficient there. But if I'm multiplying same bases, when I'm multiplying them, I add the exponent. So I get an a to the 4th. And now I'm going to do negative 7 times, again, my implied 1, negative 7, and then a squared, and an implied 1 here will give me a cubed. Now you're ready for doing the monomial times a trinomial. This time we have 3 terms in our parentheses. Again, the first one they try to throw you off because they put the distributor at the end. So it would be 2x, and I kind of overlapped that there. I can't see my exponent anymore. There we go. 2x cubed. So 2x cubed times 1 will be 2, and then that will be x cubed times x cubed will be x to the 6th. 2 times a negative 3 is going to give me my negative 6. X cubed times x, and remember there's an implied 1 there, is x to the 4th. And then 2x cubed times a positive 7, that's going to give me my 14x, and that's going to be cubed. This time again, I'm going to distribute. Again, do it in the order that they have it, because they already have it in degrees. So I have a negative AB and a 2AB. So first of all, my coefficient, I actually have a negative 1 here. So negative 1 times 2 would give me a negative 2. Now go to your next term. I have an A, that's to the first, and B to the first. So I have an A to the first and another A to the first. That would give me A squared, A times A. And the same would happen here. I have a B to the first and a B to the first, so that would give me B squared. My next term is going to be my negative 1, and there's another negative 1 there, so that's going to be a positive 1. Whoa, that was kind of a strange calibration there. A positive 1. Now again, go through each term. I have an A to the first and another A to the first, so that's going to give me A squared. And then I do not have a B in where I'm distributing, but I had one to begin with, so that keeps the B there. I'm sorry. Now, do I need my 1 as my coefficient? No, I can get rid of that 1 as my coefficient, and I'll even straighten out my B that went crazy there. And then I go to my last term. I have a negative 1 times a positive 4, so I'm going to give that as a negative 4. I have an A to the first, and there's no term there, so I'm going to leave it at no, doesn't have the same term, sorry. And then I have a B to the first and another B, so that would give me B squared. All right, so we're finally to division now. The one thing I'm going to caution you on is this is sort of this is going to be kind of distributing. You're going to divide this first term, you're going to divide the next term, and you're going to divide the last term. To get used to this especially, I might write this as 3 separate ones. We're going to work with a trinomial. So we would do 6x to the 6th. Wow, we're having some calibration problems today, definitely. Okay, let's do 6x to the 6th. And I'm going to divide that by a negative 2x squared. I also have a negative 10x to the 4th. And I'm going to go like this because when we're reducing fractions, we like to cross things out. Notice also that I am copying the sign in front of it. All right, so my first term, all of these numbers in the numerator, all my coefficients, are divisible by a negative 2. So my first term here, negative 2 goes into negative 2 once. It goes into a positive 6 a negative 3 times. My x squared can go into my x to the 6th. When we're dividing the same base, I subtract. So I end up for my first term is going to be a negative 3, and my variable is going to be x to the 4th. We're going to subtract the 2 up there. Now I have a negative 10 divided by a negative 2. That's going to be a positive 5. We've reduced that. Okay, to reduce this one, I'm going to subtract the 2, so I get an x squared. And my last term, I have a positive 2 divided by a negative 2. That reduces to a negative 1. I don't need to put negative 1 for a coefficient, but I do need the negative. And this time you'll notice that my larger term is on the bottom, so I do need my 1 there because I need a numerator. And I'm going to subtract this one to the denominator. So I have x, 2 minus 1 is 1, so that would be an implied 1, and I don't need to write that in there. Alrighty, so let me just see there. Oh, but I did some copying wrong. This here needs to have an exponent. So you've just learned a harder skill than you needed to. I'm going to go ahead and I'm going to change this to this and be in green. Okay, so an x squared over an x squared, those cancel out and make a 1. So this is wrong, and I would have that this is just minus 1. Sorry about that. So again, my last terms, I'll rewrite it so you can really see it. 2x squared, and that was a positive, divided by a negative 2x squared. I forgot my exponent. So a positive 2 divided by a negative 2 gives me negative 1. And these two, x squared over x squared, would be 1 in itself, because anything divided by itself is 1. So that would give me my negative 1. So following along in the book, this is the answer that you would see. I had a typo on that one. I apologize again. So again, I'm telling you I would write it into separate division ones. So I have just a couple extra ones here we can do. So I'm going to do a 9x squared. That's going to be over a negative 3. A negative 15x. That's also going to be over a negative 3. And a positive 6. Negative 3. Let me just make sure I copied everything right there. So I didn't leave any exponents out. Let's reduce. Negative 3 goes into 9, negative 3 times, and I don't have any x's, so my first term is going to be negative 3x squared. Negative 3 goes into negative 15, a positive 5 times, and again, I don't have a variable, so I'm going to keep my x as a numerator. And negative 3 goes into 6 and negative 2 times. One last one, and this time I'm actually going to try to do without rewriting all of the denominators like I was doing here. The problem is when you're reducing, if you cross this out, you have to remember it's there for each one of the terms. So if I can do it mentally, 35 divided by 5 would give me 7. Okay? Then I would do x cubed divided by x. So I'm going to subtract 1. That's going to give me x squared. 5 divided by 5 is going to give me 1. And I have an x as my denominator. Sorry, my minuses aren't showing up very good here. So I'm going to subtract that up in the numerator. That will give me 1 as my exponent. I don't need to write that. And then a negative 25 divided by 5 would give me a negative 5. And then the x over x would cancel each other out. So this would be my final answer. Same thing, I just did not rewrite that denominator each time. And that is how to multiply and divide by a monomial.